Everyone. Good afternoon to all my friends and colleagues from the professional community. I welcome you on this Saturday afternoon with a very interesting topic on water resource management and geospatial. So we are all aware our Earth's surface constitutes 70% of the water, which is very essential for Earth systems and processes. So it has been the basic ingredient for our life making and the most sorted natural resource on the earth. So today, as the world is changing, the deteriorating quality of water requires a robust water management and supply strategy. So let's see how geospatial information and technology with its capability to as its model for precipitation, runoff, interception, routing, sediment, transport, water resource management models are the key to decision making and integrated water resource management from basin management to reservoir operation, stream water quality, urban and rural flooding, and drought management. So today's Spatial Talk webinar series focused on geospatial technology for integrated water resource management will touch upon some aspects of water resource engineering and management. And let's see how these geospatial technology bring about the transformation in this particular sector. So today we have four speakers on our forum. Dr. Prabhakar Shukla from IIT Delhi, Dr. Mukta Girdhar from Disaster Resilient and Research Foundation, Mr. Mohan Zade, he's the expert on river basin modeling, and Dr. Nidhi Nagpatla, she is from Canada. She would be joining us a little later. So these are the speakers on the forum today, and let's begin with them. Dr. Prabhakar, sir, can we request you to put on your video?
Yeah, thank you so much.
Thank you so much.
And also
Okay, no problem, no problem. Sir, can you put your presentation on the slide mode so it will be?
Yeah. Thank you so much to and all the who have very dynamic topic. Since we have very limited time for aspects of of GIS in the water. But I'll try to give how and where we can apply this in the what we at IIT Delhi are trying to do. So for me, I am Prabhakar Shukla, and ma'am has already introduced the research group of A.K. Gosai, the Danya City and Kosa, a very known resources management.
Sorry to interrupt. I think we are unable to hear you properly.
Okay, sorry. Am I audible now?
Yeah.
Become little loud.
Hello.
I think
Yes.
some issue with the voice, no? Some issue is there at the other end.
Hello, is it working now? Hello.
Yes, sir. Yes, sir. You can start now.
Okay. I'm sorry because I have some issues with my internet as well. So just interrupt me whenever I'm not audible. My screen is not.
Sure.
Okay, so starting with the geospatial techniques, like when we refer to this term geospatial, so this is not a single technology, but a collection of technologies and such collection of such advanced technologies that help us to collect, analyze, store, manipulate in the sense of managing, distribution or integration of the data sets. So when we talk about such technologies which are much more popular, first comes the remote sensing, then GIS, then we have global navigation satellite systems. We have surveys, unmanned vehicles are there nowadays. Drone surveys are very much popular for the areas which are not accessible. And then we have 3D modeling as well. For today's session, we are will be much more focused on the application of GIS. So GIS is a tool, a system that creates, manages, analyzes, and maps all types of data sets with respect to space and time. For example, if you look at the figure on the bottom, the real world looks very, combination of so many things that it will not be easy for us to visualize one thing at one time, that too on a longer scale. For example, if we stand on the bank of any river, we cannot visualize whole of Ganga or whole of Yamuna in one go. So what we do is we translate this real world phenomena into digital world using this geospatial techniques. So what GIS does, it translates the real world phenomena into digital world using scientific approaches, where the principles of the chemistry, physics, and all those cumbersome theories are being followed. So when we talk about the application of GIS in water resources management, so if we talk about the stage wise, the first stage where we can include the GIS is the database creation. There we can collect the data set and we can analyze it, we can process it, and using some corrections or the data handling, what we can do is we can create an inventory of the data sets which is ready to use in as and when required. The second stage where the GIS can be involved in the water resources management is the data set which we have created in first stage can be used for interpretation using hydrological modeling approaches. Using these approaches, we can come to some conclusion. We can make some scenarios based on the different what if scenarios, and this can be a topographic or can be a network modeling, can be a in real world. We can also simply say the hydrological management, sewer system management, flood modeling, water supply demand dynamics, or the climate change impacts. All these things can be performed in the stage 2, that is the technical information where the GIS can be used. When we look at the third stage, the knowledge sharing, this is really very important, because as a researcher, whatever we do it for society and the welfare of the people. Generally what happens, we do some research, the reports are created and the reports are transferred to the policymakers or the higher level people, those who are sitting in the governance places. So the policy beneficiaries or stakeholders, those who are in the ground, they are not aware what kind of work is going in our background. So the basic idea is to disseminate the finding of our research to the people, those who are the stakeholders of the the water body or the area where we are doing our research. So GIS can help us to formulate a dashboard where all the findings of stage 1 and stage 2 can be incorporated. This can be a website, can be an application, can be an automated message which can be transferred to the stakeholders. For example, if we are doing the flood modeling in NCT of Delhi, what we can do is the findings of our research can be disseminated through automated message or in form of some application notification or some website, and it can be informed to the people, those who are living in low-lying areas, that yes, your area will be flooded in coming hours or coming days, so you need to vacate this and you need to relocate. So such type of information system should be there. So GIS can be very much effective in disaster management as well. So these are the stages, and when we come to the specific application, this can be in hydrology, hydraulics, environment, or the groundwater. Coming to this slide, which has been published by the Press Information Bureau, Government of India, this shows the green box shows the geospatial technologies which are available as of now. As I mentioned in my first slide, the application of remote sensing, and then surveying and the positioning and the spatial analysis. If you look at the second box, that is more about the digital technologies which are available and being used in the water sector. And the third and the blue box is the replica of what I have mentioned in the previous slide. Although it does not cover all the fields where the GIS has been used, but Mainly it is used in the smart water grids classification and classified and thematic analysis of watersheds, surface water modeling, groundwater modeling, water quality modeling, and this water availability, water supply, demand dynamics, socio-economic modeling. Different kind of hydrological modeling approaches are there. Also, the impact of climate change can be accessed using this GIS and this geospatial technologies. So without going much into depth, much depth or discussion or the topics of where these can be applied, based on this discussion as of now, I'll be moving ahead with the what we are doing at IIT Delhi. So these are the major projects where the GIS technology and the geospatial analysis techniques are being used as of now. For example, the Jal Jeevan Mission, the National Mission for Clean Ganga, and then we have this Atal Bhujal Yojana, and also the National Aquifer Mapping and Management Program. These are few examples where the GIS has been successfully applied, and they have very fantastic results because this, especially this National Aquifer Mapping and Management Program, this is very effective and very much more informative data. Any researcher can get some useful information which was earlier not accessible to the researchers. It was very time consuming and also very costly. So such information have been made available to the public for further research. And now the question is how the remote sensing or GIS or the digital elevation model, all these activities can be integrated into the water resources management. So what we do is one possible way is hydrological modeling. Hydrological models, they give us a platform where remote sensing provides some inputs, for example, the satellite images, and the GIS provides a platform for simulation or working of these hydrological models. And when we talk about the hydrological models, there are n number of hydrological models which are being used by the several researchers across the globe. For example, the SWIM model, that is stormwater management model, can be used for the urban flooding, and there are PC SWIM paid version of it, and then we have SWAT, soil and water assessment tool. We have mode flow for the groundwater. We have Qual2K for the water quality monitoring and the prediction of the pollution load in the different stages of river. So there are many more, much more information is provided in the link which I have given here. And primary inputs for all these models can be obtained using this remote sensing and the GIS tool. So moving ahead with this, what are the priorities if we are applying thinking of using GIS or the remote sensing things in the water resources management? So first priority is to identify the ways in which GIS can facilitate more effective or more efficient water resources management. That is the first thing. And second thing is to develop the methods or the approaches that address the specific water resource challenges and problems with respect to basin or the any specific water body. And third is to train the existing and the next generation of water resources engineers, those who are dealing in this field. For example, there are few people in the government organizations or the private sector, those who are familiar with these activities or these tools and techniques, but they are not that much confident, or sometimes they are not aware what in selection of the tools, that what kind of tools can be used in this. So training is needed for both existing and the next generation of water scientists. These are the three priorities. However, there are many other priorities, but these three seems to be on top. As per, this is in my personal opinion. I cannot say that these are generalized. Keeping all these discussions in the mind, so at IIT Delhi, the team has team IIT Delhi in the civil engineering department under the guidance of Professor A.K. Gosai. We are working on water security and sustainable development hub. This was started in February 2019, and in collaboration with the Newcastle University, University of Oxford, SPA Delhi for policy and planning, University of Leeds, then we have WLRC from Addis Ababa, International Water Management Institute, and University of Cauca, and then UTM Malaysia. So, and also the Newcastle University has two campuses, one in London for this engineering, and Medical University in Malaysia. So all these researchers from all these institutes, they have collaborated together, and this is first of its kind project in the world which is dealing with the so much dynamic fields of Sustainable Development Goal 6 that deals with water. You can see the wheel on the bottom. The aspects which are shown here, all the aspects have been taken care through this sub-activity. So from where the idea of water security came, this is the first question. See, there is no globally accepted or universal definition of water security as of now. And the definitions keep changing and depending on the requirement of environment and people and the lens through which the user sees this. So on the screen which you are seeing on this left side bottom, this is the most referred definition as of now. It was developed in 2007. So the water security is defined as the reliable access of sufficient quantity and quality for people, environment, as well as the economy. And we have to manage water-related risk and disasters both. So keeping this in mind, the guiding star, that is our primary aim, that we are working in NCT of Delhi as a study area. So we are working on the water security of environment and the people both. The first outcome which we are expecting at the end of our project is that there will be effective and equitable management of water resources for environment as well as for human. And second is the extended and improved network of water supply and the sewerage network in NCT of Delhi. That is our pilot area. And then we have efficient use of water by the stakeholders by the formulation or incorporation of the outputs in the policies. And then we are expecting that based on that policy, there will be proper governance and the regulatory. So when we look at this NCT of Delhi, a stretch of 28 kilometer passes through through NCT of Delhi, but 80% of pollution load is contributed to Yamuna from NCT of Delhi itself. And if you look at the main risk, then there is a population growth, infrastructural aging of infrastructure is also challenge. There are non-revenue water when there are losses of water, theft of water, and all these things. And then we have dependency on the groundwater around 10%, which is being reported in the economic survey. So there is a depletion of groundwater in NCT of Delhi, and then also the climate change. The groundwater level have been declining. Groundwater level has been international issue. This has been covered in several newses also. So and also if you look at the water infrastructure in NCT of Delhi, the water supply, sewerage, and stormwater network, these are inadequate as of now. So keeping that in mind, what IIT Delhi team is doing is that we have divided our study area into 4 different scales, and we are using systems approach to achieve the water security of NCT of Delhi. So the first scale, area for the surface water analysis is the Upper Yamuna Basin, because the water supply to NCT of Delhi, it comes from the Yamuna. And then the second scale is NCT of Delhi, where we are working on the pilot area level. We'll be looking at the water supply and this groundwater things. And then we have Barapula Basin. This is our pilot area. IIT is also part of the Barapula Basin itself. And then we have IIT campus, because IIT campus is a controlled campus, and it has the capability to represent any urban area. This is a good population governance policy and all those aspects. So what we are trying to do is we are trying to replicate our methodology in the IIT Delhi campus. Once the methodology is successful, this will be scaled up to the Barapula and then NCT, and if possible to the NCR as well. So these are the 4 scales. In the Upper Yamuna Basin, we are working on the hydrological modeling. We are using
voice is missing. There is
Hello?
a disturbance, no?
Am I audible now?
Yes,
If you close your video, it may improve. If you close your video, I think it will improve.
My video
He's
is
already on the video is closed. Sir, there is a noise coming from the participant, somebody who has opened the mic.
Open
So
just to request him. If he close his video, I think it will improve.
Sir,
not
his
able
video
to-
is already closed. Sir, we request you to please.
okay.
Sir, you continue, sir.
Okay, so in Upper Yamuna Basin, we are working on the hydrological modeling. For the surface water, we are using ArcStrat model, which is again GIS based. And then we are looking at the water availability scenarios for the present and as well as the climate change impact. We are also looking at the water quality analysis for the secondary data, and also the water quality modeling is being performed using Qual 2K water quality model. At the NCT level, we are looking at the overall water audit for what is the availability of water, where it comes and where it goes, and what are the losses. Then we are looking at, as we are looking at the surface water, we are also looking for the groundwater system. We are using mode flow model for that. And evaluation of water supply and treatment facilities is also being performed. We are doing water quality analysis at both Upper Yamuna Basin and the NCT level, and the economic analysis of water services, where we are using this circular water economy approach. Then at the Barapula level, we are doing water supply, sewerage and storm drain network infrastructure analysis. Again, we are using the SWIM model and this EPNet model for water supply and this sewerage network analysis. And we are using circular water economy analysis for this Barapula as well. And then we are going for field surveys, doing we are listening to the problems of people, what kind of problem they are facing, so that we are ensuring that their voices are being heard in our research. And while creating scenarios, these voices will be included in that, and the baseline will be set up, which will be supplied as a baseline to the policymakers. And all this information will be disseminated at all the 4 schools, will be disseminated through a GIS based framework, which will be supplied to the stakeholders in form of some messages or the web links and infographics as well. So as of now, we have set up our baseline and we are ready with our current status of the water infrastructure, availability, supply, demand, and losses, and this economic analysis as well. So all the baselines are available with us, and we are planning for a stakeholders workshop where we'll be disseminating these findings. And that's all for me as of now. And if you have any queries, or if you want to know more about this research, please write me on this email address and I'll be happy to answer the queries. Thank you.
Thank you, Dr. Shukla. It was a wonderful presentation, giving us an insight on your project on the water security and how geospatial technologies are being, you're utilizing those technologies in building up that framework. So thank you very much. And now we move on to our second presentation. Dr. Prabhakar, can I request you to close the sharing? Yeah, thank you so much. Our second speaker on the forum is Dr. Mukta Girdhar.
Thank you so much, Swati, for this wonderful introduction and giving all details, information about me. Thank you so much. And first of all, I would like to give thanks to WGC for organizing such a wonderful webinars, which really enrich everyone with the aspect of different geospatial avenues. As you know that my expert area is GIS and disaster management. So I'll be taking topic related to this disaster management. So my topic is flood. So let's see how India is vulnerable to flood. And just give me 2 minutes. I'll share my presentation. It is visible?
Not yet. Yes. Can you put it on the slide mode, ma'am?
It will come. It will take another 1 second maybe. I don't know, but even it is not moving, slides are not moving.
Can you open it on a slide mode and then select into sharing? I think then it will happen. I think you should start.
From my side, it is on screen mode, screen sharing mode. So even it is not displaying next slide. I think we have to go like this.
Yeah, please go ahead, please.
Yeah. So you can see from this image, this one is Indian. This one is an Indian plate, which indicates the flood-prone area, and it has been extracted by the lot of scientists that this area that is vulnerable to flood, and each year floods come into these areas. This one is a river basin map of India. You can see the blue lines, which indicates that river flowing throughout the plates. And this one, that is a satellite image, and you can see it's a complete northern side of Himalayan range, and lot of rivers, they are flowing from from Himalayan to Indo-Gangetic plains. Along with there is lot of tributaries. This one is a detailed map of main, you can say, river basin, Lower Ganga basin, Upper Ganga basin, Brahmaputra basin, Yamuna basin, Kaveri, Narmada basin. So every year, or you can say some are the other year, we are facing lot of flood problems. Earlier, it used to come only on the river, but nowadays you don't, nobody can judge, nobody can even think that floods can come from any side. Last year, we have faced the glacial outburst, and which changed into a lot of havocs and devastation. And before, a few years before, we also faced Uttarakhand flood, which really near about 5,000 people have been died and 4,200 villages were affected. From these images, you can see how much devastation was there after this flooded situation. There is another flood which is known as the Jammu Kashmir flood. People never thought that this area can also face the flood situation. Suddenly, river changed its track, and the area have been flooded, and flood was so high that all the hospitals, they have been submerged. People, it's really difficult where to go for medical attention and all those things. A lot of people, or you can say the newly born babies, they were the inside, and so many people, they were into the intensive care units, and because of floods, electricity were gone, and these people, they have been died. Situation was really devastated. So one picture I have seen that I'm not putting here, but in that picture, somebody had died, and the first ground floor that was submerged. People came there through the boat to take his body, and the other people, they have just thrown his body from the door to the boat, and that is how they have collected. So really after the flood, the situation will become very grim. This one is the scenario how people have been suffered after the disaster. This one here, people, they are crossing after this Uttarakhand flood with the help of army people and NDRF people from one place to another place. In this Jammu Kashmir flood, 45 people killed and 12,000 houses were damaged and 9,06,000 evacuated. After that, there is a Chennai flood. This one is again, you can see that flood have been engulfed all the cities, and it's really impacted, or you can say destructed all the lifeline facilities, and it becomes really difficult to move, to drink, to take food, even to start the kitchen. What is flood? Flood is a mass of water rising. These are some basic factors. As the time is shortage, so just I am going on the basics. Floods come because of heavy rainfall, structures ground, rapid snow melt, deposition of silt, deforestation, urbanization, dam failure, and temporary dams. Apart from that, there is some factors which we are contributing, and those factors are location of communities on floodplain. If you talk about the Uttarakhand flood and Kashmir flood, all this because of the people, they have established their facility in the floodplain area, or you can say the side of the river bank. Lack of awareness of flood hazard, reduction in the ability of land to absorb water, because everywhere we are putting concrete things and there is very little place to absorb this water into the ground. If you think about the Delhi itself, we are facing a lot of problem. Whenever little rain comes, we have to face the urban flooding. And after urban flooding, there is lot of mishappenings in every year. So dam failure is the another cause. Cloudburst is very important because the cloud burst, it happens once time in a lake, and this cloud burst was so strong and so heavy that people who are the tourists, they have just, you can say, some surrounded by the cloudy mud, and it was difficult to come out for them to this cloudy muddy to plain area, and they have been died. Near about 8 tourist visitors, they have been died to just they have been you can say stuck on the muddy area. So it's really difficult, but now we can see that how this technology that can help us. These are some, in fact, structural damage to a building, destruction of roads, rail lines, bridges, boat, transport vehicle, historical monuments, and communication system. You can see from this image how this railway track have been submerged, and this is image from the Mumbai. They are also facing every year urban flood, and NDRF people have to really rescue Mumbaikars from one place to another, and that is the time when local and all the transport system have been stopped. Death due to electrocution, because sometimes current have been discharged to a water and people have been got impacted. These are some secondary effects: public health, vulnerability, economic impact, security impact, law and order impact. All these are the consequences. So now we have to see that this is the scenario of India, and all over India we are facing every year the flood situation. Now we have to see how this technology, geospatial technology, help us to really reduce this impact. Though it is, you can say, the good amount of this technology have been not utilized by the flood in the flood scenario area, flood departments who are taking care of this. But even then, some they have been used. Let's see how. So in 2010, when Punjab and Haryana that had been flooded. So this one is the image of 9th July 2010. Through this image, you can see how much area is flooded. And at the same time, they can extract how many people have been suffered because of this damage, where are the shelters, where are the hospitals, which hospitals are in a safe condition, where we have to evacuate these people from one place to another place. After in certain duration, you can say this image, that is 9th July, and this image is 14th July. So near about there is a gap of 5 days. You can see a good amount of water have been receded from that flooded area towards the water. So certain area is still flooded, and here they have to work again to provide the rescue and relief work. So based on these information, disaster managers, they can take a right action, and they can provide food, rescue, relief, and drinking water. So this one is an image of 19th July. So after certain duration, we can really visualize the things with the help of this technology. Yes, water is now receded up to this limit, and now we have to work, and they can focus their work based on that. There is another utility that if we can map the near last 20 years of flooded area, so we can really take out that this much area is flooded till now, and maybe there is few more chances because of this climate change and because of some other things. Maybe this much area can more affected, and based on that they can prepare a flood management plan. For example, in the cyclone, geospatial technology is fully utilized, and in all the coastal area, government just see based on their wind speed and the heavy rains how much area is going to be inundated, and till where we have to evacuate people, and where to evacuate along with the their rescue and the relief material. This one is a good example of I don't think I'm not saying it's a good example, but yeah, it's very effectively this technology have been used. This one is an image of Bihar Kosi flood. It was came in 2008. So what happened in this Bihar flood, that if you see the first image, this one is the image which indicates that water is flooded into this area. But if you see the lower side of image, it is the original, its drainage pattern where its river is flowing. Suddenly, so what happened earlier, this river, it is flowing straight, and because of meandering impact, this river has changed its course, and it started flowing in the sea direction. But in that day, particularly on that day, there was a heavy rain and river changed its course. And during this time, in this sea section, there was a lot of settlements. And the same day when river changed its course, and the same all settlements, they have been submerged. And Bihar area, they have to face a lot of human loss and the infrastructure loss because of this flood. So how many people have been suffered, and all the statistics have been calculated because of this geospatial technology. So this one is an image. There they have exactly calculated how much area have been flooded and how many villages have been submerged because of this flood. Now you see the Assam flood. Every year these floods come into this area, and the complete this one is a layer which has been incorporated year by year, and if you enlarge it, it is available on their Assam government site. And if you enlarge it, you will see how many villages have been passed, and they have been submerged, and now what are the possibility in the coming future. So that is all about me. There is one more example which I would like to say. In Barmar area, Rajasthan, they have changed because of flood, their topography has been changed. There is lot of rain, and this water has not been percolated down because of some clay structures, clay rocks were there, and they had been swollen up. So water was standing, and it was really difficult. Then government, they have decided to bring this water from that place to the river through the trains. So train went to that particular spot. They just take out the water and then discharge this water to a rain. And after the certain area, then they have changed the remaining water into a lake. And in throughout this process, they have used this technology very effectively. That's all. If you have any queries, please let me know.
Thank you, Dr. Mukta. We'll take the queries in the end. So thank you so much for your presentation and giving us an insight of all the floods, how floods are being managed in the country and the number of floods across. So thank you very much. May I request you to please stop the sharing so we can move on to the next presentation. Our next speaker is Mr. Mohan Zade. He is an expert for river basin planning and integrated water planning. He's So over to you, Mr. Zade.
Thank you very much, organizer, and especially thank you for this nice introduction about me. And I really thanks for the invitation to share my experience on the various aspects of hydrology and water resource management. Today, I will talk about two things because today's topic is a geospatial technology for water resource management. So essentially, it has two topics. One is the first geospatial and all kind of remote sensing and GIS kind of stuff. And the second is the water resource management. I would like to emphasize this geospatial technology is just a tools or data, and then it can be applicable to anywhere. But its utilization in water resource management is immense because of the scales and length and breadth that the country is facing this agriculture and water management, and looking at the scales, it is massively important because of its advantage of this geospatial technology, which can handle the many length and breadth and this various spatial scales also. So let me share my first presentations. Okay, I hope this is visible to audience.
Yes, Mr. Zade, it's so visible.
Yeah, okay. This is first is a geospatial technology for water resource management, and I always believe if you can measure, you can manage. So this is the first thing that we must understand. If you can measure, then only you can manage. And geospatial technology helps in measuring many of the aspects which were not available previously before 2-3 decades. Now the immense power of satellite data and the models and artificial intelligences and machine learning algorithms, these are now really helping to manage the water which is very scarce in those periods. I will just touch upon this about how this water resource management has been evolved in India or elsewhere. Particularly, I will be just sharing this history of water planning in India. Earlier, there was a need of more of supplying more water to the areas, to irrigate more areas, to increase the food security and all those things. So during 1956 or after the independence, our first priority was to develop or build the more and more dam to have a more food by irrigating more area and that is the way. So that time it was only the prime objective was only to provide more and more irrigations, and that was the only emphasis was on to developing the infrastructures. So in 1956 it was more of engineering aspects, and then if you talk about the latter stage in 1985, it was about developing a master plans. So a series of dams or series of kind of a canal networks where the water can be thrown to the irrigation areas and irrigate more areas. Those kind of things were happening in that period of time. Now the things have been changing. The things have been changing after the 2000, where the now from the development or engineering aspects, now we are moving to the management aspect of the water. And this management aspect is not only talking about the only water, but we are talking about the more of management aspects or the monitoring aspects of the water. Now, if you see here, the curve is also shows that infrastructure is going to be a decline over the period of time, and the governance or the management aspects is going to take a place on the infrastructure and the development, infrastructure and the management. So basically, there were two phases: water resource development that's previously happened, and now the second is a strategic approach to the basin planning. So this is why this basin planning also is very important, because now I will show you why we need the basin planning or integrated water planning or management. As you know, the water were free commodity in earlier periods, and still it is a kind of free only. Therefore, we much not care about the water. We just use at a free commodity. But however, in the today's, if you see the today's scenario, the demand for water resources are increasing because of many other things like population pressures or economic activity that is intensifying, and as well as there is a more water competition from the other sector than agriculture. If you remember the earlier periods, the agriculture were using about 90% or 95% water use in the agriculture sectors only. Now the things are changing. The things are changing more, because that is also changing because our urban populations and rural population divide in earlier period. If you see, the urban populations were only about say 30 or say 35%. Now the things are changing. The urban and rural divide is almost equal. If you take the example of Maharashtra only, now the 2011 census says the urban population is now 45% and rural population is only 55%. So this is going to change the scenario of, and at the worst situation, this climate change may impact the water ability. And the third thing is the water quality, which is deteriorating every day, and that is also reducing the water availability. The second is the water and determinant systems are degraded. Now the pollution is such an increasing at an alarming stage at every stage, and that is by reducing the water. It has a detrimental effect on many aspects, on the surface water as well as the groundwater, and that as reduces the water availability on the surface as well as the groundwater. And the second is the more human activity has been introduced in the forest and nature creations. Of course, we do have a right to enjoy the nature also, but the things, the way we were being encroaching the environment is not at all a very healthy systems or win-win situation for the humans and the nature. The third option, third is the management is a little complex. People try to avoid this competition and conflicts between the sectors because of many if and buts and many rules, regulation, policies, and all these things has comes into the picture, and it becomes messy when it comes to the management. And the second is very difficult to balance the economic as well as social and environmental process. So those things are being now under very intense pressure on the basins, and that is the reason it is being more challenging to have an integrated water resource planning. Now there are chances that your own individuals' freedoms also been curtailed, and that is the reasons. People are facing a little pinch, or being facing little curtailment and loss of freedoms. And this is what we have to do is for the planning for the future and young generations. This is what we have to pass on to our future generations. If we keep on deterring the same way that we were doing it, that is not going to sustainable, or that is not going to be a very win-win situation for the human and the nature. So these are the basic things why we need the integrated water planning and management. Now, once this, if you know the water integrated water planning and management is required, then needs the why we need a geospatial data and the needs, because every aspects, if you take about any examples of water management, like let's take a now the earlier speakers talk about the flood, and earlier and the first speaker Dr. Prabhakar Shukla also talk about the basin, and then further down to the urban cities. So the scale, if you see the scale of planning, it is ranging from the basin to your catchment or watershed level. Now if we have to deal with these from the basin to watershed level, you have to see the how efficiently data can be available for managing or planning basically. So right from the planning and then monitoring and measurements and the monitoring, this geospatial data is now plenty of data is available through the open source as well as the proprietary data shapes. Now earlier the data was a little bit hesitant to share, but the policy has been changing as per the needs of a day, and that is why this policy is also helping. The data is now freely available, and that is the reason this geospatial technology is now been available along with the model. Now just data can't do anything, so we need a model. In the earlier first presentations, Dr. Prabhakar told about the many models they have used, like a Stormcat and then SWAT and then river basin models and water quality models. All these models are working on the large scales. Now, if you want to talk about really large scales, then we must think about only the geospatial. This is the very big advantage of this geospatial technology in the maintaining or the planning of the water resource management. So this data comes into the model, a different hydrological model, different water quality model, different flood and disaster models, and different monitoring and measurements also. So those are also helping in this data. Now here we also think about the many things, like a geospatial not alone can do the one single things. It has to be integrated with many other things, like a SCADA. We have the SCADA systems where we have the measurements of the discharge or measurement of water level in the reservoirs, which gives the data and flash to the data on your board, on your computer, and you can immediately put into model and develop and get the result and take the actions. So right from the geospatial technology along integration with the other technology, now it is being useful even for the implementation and maintaining and measurements. This is very important in the model also. The third is the visualizations. Now you get the models, results, and other things. Now you have to see the visualizations. Now if you see the flood and the disasters, you have to see the visualizations. You have to see the impacts, the likelihood impact of those disasters, so that the advanced planning can be done for avoiding or minimizing the disaster, like saving lives, saving properties, or saving the infrastructures, which we put a lot of money into that. So this kind of visualization is also now very important in this geospatial strategy. The third is the scenario. Now the fourth aspect of the scenario is now to develop as I told you, this is for the young generation in the future. Now the future we have to visualize right now and to see the changing scenario in the urban, changing scenario in the rural, changing scenario in the water used by the agriculture and the industries and the power and the creation and the river health and the river health, and well as the water for need for the ecosystems. So we have to model those scenario and see the changing situations, and then take the likelihood strategies and prioritize actions. The based on the scenarios, then we develop the strategies and prioritize actions. Those are need to be strategized. Now these strategy and prioritize actions are not only for the technocrats, not only for the scientists, not only for the researcher, but these are the strategies and actions to be give to the administrator, the bureaucrats, the politicians, which are very important, which they play the very important role in the water resource management, to take the policies at the state level, policies at the national level, to take actions to bring out the new bills, to bring out the laws and the amendment the laws and all those things to be implemented for the future of water resource management. And the last is the result and monitoring. Now, this is very important. Result. Once you have a strategies and implementation, then you can monitor those results are as per the expectation or changing situations. Now, the dynamic, this geospatial or the water resource management space and time domain. Every time, every year, every month, every season, these water behaves differently as per the situations, and therefore the model, yesterday's model is not applicable today's model. So you have to change as per the needs of, and that is why they are forecasting of those models. Once it is calibrated, once it's validated, then calibration calibrated, this model has to be applied in the real life situations where where the geospatial technology helps in getting the accurate data, timely data on the large scales, and provide the input to the our system and to take actions. So this is overall the picture of any systems where the geospatial technology can be helpful, not only that, but I will touch upon this mostly on the integrated water resource management, where I have worked in Tungabhadra River Basin planning. So I will talk about the river basin planning. Now, if you see the river basin planning process, it is talking about not only the when I talk about the integrated water system management, then you have to deal with the many departments, almost 60-70 departments you have to talk about, and the coordination with those departments, fetching the data and all those things. This is the secondary data. Now, that's the most important data source is the geospatial, where the modeling, river basin modeling, we have to do it, and for that we need to have a many kind of a data from the watershed level, from the ground water quality level, groundwater level, streams and rivers and the reservoirs, and all those things of data are required at a basin scales. Now, if you come to the but the basin accommodate many things like a catchment, sub-catchment, then command, non-command, agriculture area, non-agriculture area, as well as the irrigation area and rainfed area. Now, every situation is little different. For that, you have to do the many specific studies also, and therefore for the Mascot application, that is also very important studies for the managing or how the system of canal irrigation system is behaving right now, whether it's optimum. Those things has to be done, and for that also the geospatial technique like remote sensing data and the GIS data, those are useful. The second important is the climate change impact. This climate change impact also they have to do it very rigorously to see the impacts for the future. Now, this also has been done. This has been done for the river basin, Tungabhadra river basin planning with the help of Indian Institute of Science. And then we develop a SWAT model and the change in scenario, and then how the stream flows are changing over a period of up to 2100. So with the changing weather parameters. Now, here the most important thing is I would like to mention the data is now freely available. That is very important to model any kind of climate change forecast. Climate change forecast, weather forecasts are now available in many of the website of IIT Mumbai or Pune institutes where these data are available. Water accounting, which is also one basic things for to develop what is the water account of the sub-basin and or the basins. So these are water accounting specially used only the open source data. And if you see, I will not go about details about this water accounting, but it is just I will tell about the this water accounting takes about the rainfall data from satellites, or water resource data from the satellites. It takes the models of hydrology models to accommodate the runoff and all those things, and the water productivity. So these are the some of the things where the important data is from the geospatial, and then we based on that studies and modeling, then we develop a river basin plan. And this is not only the technology. From the technology side, we do the stakeholder participations. We have many multiple stakeholders at various scale, right from the government level at the higher authority like the chief secretary level to the bottom at the very sub-basin level or the watershed level that we did, and then develop a river basin plans. Now here we see that these number of things are required for the river basin, right from hydrological assessment, sedimentation studies, water counting, water productivity, watershed, groundwater stream flows, water quality assessment, river health and environment, climate change, and social and stakeholder mapping, and baseline economic indicators. So number of studies are required for the river basin planning, and that is why the geospatial technology helps in getting the accurate as well as the timely data for those things to do the planning process. This is just an example of this Tungabhadra river balancing. I will just go about this water scarcity. If you see the Krishna is 936. As per the Falcon mark, if it is the water is less than 1,000 cubic meter per year per person, then it is called the scarcity. And if it is less than 500, like Vedavati, if you see the only 225, it's called the absolute scarcity. That means it needs much more attention right now. So those are the things that we are not. I'm not going to detail about those things, but this is how we plan. And then this is the significance of Tungabhadra, where how this importance of Tungabhadra, because anything we have to do it with the justification and the logic why we are doing it, because it has very economically importance for the Karnataka, as well as it has contributed more than 20%, 22% to the GSDP, 30, and it contributed more than 37% state food productions, contributed more than 30% of the state milk productions, and so on. So those are the things which helps in why it is important for the river basin from the perspective of the government side as well as from the perspective of economic side. Then we set a vision for anything to be developed. We need to have a vision for that, and so we define a vision for the Tungabhadra, that is securing supply of good quality water for all domestic, agriculture, industrial, and environmental, and that maximize the benefit to the states. So this is the goal for any basin or sub-basins where we need to develop on it. And once we study all these present patterns and then current scenario, then we found that there are many challenges to our issues that need to be taken care in the planning process. And these are some of the climate change is projected to reduce the flow, and there will be more frequent severe droughts. Water security is very low because we found that there is a scarcity of drinking water supply during the summer seasons for many of the areas. And then we found that stream flow and water quality monitoring is very poor, and that is the reason we are unable to track where is the water quality is getting poor and where is the good quality. Water quality rivers are monitoring. It is monitoring, but it's still degrading. There are less coordination with the sectors and institutes that's working in the waters on that basis. Inflow to the reservoirs need to be secured. Groundwater is heavily depleted. This is the most of the time. This is a scenario for most of the basin now and need protections. Sedimentation in Tungabhadra reservoir and river is serious. Now, sedimentation in the reservoirs, if you see these reservoirs are mostly built before 40, 50, 60 years. Now, these are sedimentation is the major issues in those basin, reducing their water storage capacity, and hence the subsequent consequence of supplying water to the various users. The river health is very poor and need rehabilitations. Now here it is much of the attention. Now I will just quote one example here. The Krishna KWDT award, the Krishna Water Distribute Tribunal says that you have to release 2% of water to the river every year, but it is never followed because of the many administrative or management issues. These are never followed, and that is why the river health that is poor downside the reservoirs, and the frequent occurrence of drought causing much of the economic losses to the agriculture community and the exploitation of groundwater. So these are some of the issues that we found using these models, data, and then techniques and various studies. Then we found that these are the 4 key result areas or priorities areas where we need to work on this thing, that like a securing supply of water in the rivers, sustainable supply of groundwater and management of critical watershed, protecting water quality, and then IWR governance for K8, K9. So that's Tungabhadra and Vedavati. So those are the things which, and these are some of the why it is required securing water supply rivers, where if you see here on the upstream side, these are the heavily supplied water, but those waters are being available, but it is critical now these days because much of the water is in release downstreams because of the downstream needs, but they also need to be protected. Then watershed, if you see there are many watersheds here, you can see the red color watershed. These are the more critical watershed. And here the most of the things are done in the GIS and using the data that is available with the various government agencies. Red color, so these need to be protected. So now if you see here, especially you can see the number of watershed and where are they located. These watersheds needs attentions. Water quality, if you see here, the water quality is mostly deteriorating those areas, which gives an indication that the contaminations is more on those belt, because of the many other things like a pollution, non-polluting source, or non-polluting point source, as well as the releasing discharge to the rivers, untreated discharge to the river from the urban and village conglomerations. And the fourth is a water governance, because this we talking about the management. So that is why this governance also very important. And then we propose many different aspects. I mean, two aspects to the government, that we should have a river basin organizations, or kind of a institutional arrangement where all the different stakeholders work together for one common goal. And that is why this now, if we heard about this now also in the ministry, the Jal Shakti is now been integrated with the water supply and sanitation, as well as the Ministry of Water Resource. Earlier those were two entities were acting independently. Now they are into one platform, and that helps us to take the decisions faster, as well as to implement those things. That reduces the time, and the management is easy. Now I'll just talk about this, how this IWRM and river basin planning and management, the Indian approach. Now the central agency has taken very good steps and identify as basin as a unit for the planning and development. And for that they have formulated many rules, regulation, policy, guidelines also, like IWM guideline in 2010, and then National Water Policy 2012, National Water Framework Bill 2016, and the one of the most important in recent time is River Basin Management Bill, which was introduced in the cabinet also, and likely to get approval after the state's concurrence. And once, as you know, the water is the state subject, so state subject, and therefore the state has to take a proactive actions on the IWRM and river basin. And in India, there are very good examples, like one is the Pamba River Basin Authority in 2009. The Kerala has formed, and they are doing it. They have developed the river basin plan, acting on it now. The second is the Advanced Center for Integrated Water Resource Management, ACIWRM, that is in Karnataka. They have taken these initiatives, and they have formed this society under the Water Resource Department to implement the IWRM principles and river basin management in the Tungabhadra, to set up the guideline for the rest of the India also. And the third is Maharashtra Water Resource Regulatory Authority, MWRRA, in 2015. So there are some needs revisions and kind of a continuous process. As I said, this river basin planning is a continuous process, so it has to be evolved every time. It is not a fix. It has to be evolved with the experience, with the approaches, and with the management styles and the functioning of the government. This is the second example that we applied this geospatial technology and the data and the tools in the Narmada Valley Development Authority, where we have to generate the feasibility reports, as well as the detailed project reports for the medium minor irrigation projects, to utilize the water share of Madhya Pradesh. Because in NWTT award, they have mentioned that by 2024, you have to actually give the plan to utilize this water. So integrated water planning was done using this geospatial technology of 0.6 meter resolution data, and then 0.5 meter contour intervals, and integrating many. Yes.
Excuse me. Can you wind up a little faster, because we have one more speaker on the forum?
Yes. This is the last slide.
Okay. Right.
Yeah, this is the data that we have used for the developing integrated water planning for the Narmada Valley Development Authority to utilize the NWTT award water shares for the Madhya Pradesh. And this is the whole approach that we have followed we have the different models like a runoff to assess the runoff models, and then hydrologic assessment, and then prepare the various. I will just give an output of this example is that within the 2 year period, we generated more than 400 minor irrigation projects and 6 medium irrigation projects using this technology within 2 years time. That is the advantage of the geospatial technology. In a quick time, you can plan many things at once, and that is the biggest advantage of the geospatial technology. And I have personally experienced it in 2 examples in ACI WRM as well as this NVDA Bhopal, where the geospatial technology is used immensely for planning water for the catchment level as well as for the basin management. Thank you very much for kind patience. I think I have extended my talk little more. Thank you.
Thank you, sir. Thank you so much for a wonderful presentation on river basin planning and integrated water management, how you have successfully used geospatial technologies in implementing these programs. Now, I would like to invite our last speaker, Dr. Nidhi Nagabatla. She is a Senior Fellow and Cluster Coordinator for Climate and Natural Resources, United Nations University, Chris, and Adjunct Associate Professor at McMaster University, Canada. Over to you, Dr. Nidhi.
Thank you so much. Can you hear me?
Yes, we can hear you.
Thanks for the confirmation, and good afternoon, good morning from my side. It's still dark out there. The sun is about to come. It's sort of winter dark days here in Europe. But I bring you all the best for the season. And before I start, I also want to thank the organizers for giving me this platform to share some insights about the work that we are doing as a UN agency in the water resource domain. I don't have a lot of slides, but I may be able to show you some snapshots of the recent work that we have conducted, just as an example. But I would like to see this time that we have left to be more interactive. So maybe some questions, maybe sharing of experiences, so that we can maybe also use this opportunity to learn from each other rather than me doing that job alone. Okay, so let me try to see if I can share my slide. If not, then we'll make it more conversational. Are you able to see that?
Yes, yes.
In the presentation mode. So I thought of maybe just calling it, giving this presentation a name. So I could just call it Water in Pixels, but I wanted to, and the previous speakers already set a good ground on what water crisis, water security, and water insecurity, water scarcity looks like in the Indian context, but the global context is not largely very different from that. Even developing countries, of course, but even developed countries suffer or are exposed to the vulnerabilities of water quality, water quantity, that's too much water or too less water, or water extreme events like floods. And I can quote the European floods of 2021 in July, where many countries had to witness a loss of life despite of all technological advancements in early warning systems. There were the infrastructure loss was worth billions of euros, and that was a sort of a lesson or a call that we are still underprepared to address multiple impacts and multidimensional crises that loom around the water domain. And to sort of begin that work where we can apply tools like remote sensing and GIS, we started identifying water crisis scenarios these are not as comprehensive as the climate change scenarios, but at least they give us some sort of a boundary conditions to define our work, to apply tools, to create database and information systems. And you can see on the screen, these are 6 scenarios that we have identified in more or less all encompassing domains of water, how it's used in different sectors, municipal, household, rural, agriculture, infrastructure. And these scenarios were for us, for our internal research initially, but then this report was launched just after the Sustainable Development Goals was launched in 2015 to give. And then we were also mapping the quantitative or statistical trends and patterns to give this report a bit of a shape and form, in the sense that we are able to understand things in a quantitative manner, but also in a sort of a so it's a mix of qualitative and quantitative indicators, some of which you can see on the screen. I'll sort of run through quickly. So these are the domains where we focus our work in the water sector, and most recently we are, as UN agency, we are supporting the implementation of Sustainable Development Goals. And noting the importance of water, Sustainable Development Goal 6 is more or less about ensuring sustainable water futures for everyone. But water is also reflected in other sustainable goals very explicitly, or sometimes a bit more indirectly, like climate action, life below water on coastal systems, and life on land indirectly when we talk about food security, food security directly in SDG 2. So a sort of a big water footprint in Sustainable Development Goals. And in the implementation strategies, geospatial and remote sensing tools have shown a lot of promise to monitor, to track progress, and to define long-term sustainability interventions, projects, and activities. Other thing which is used as our base frame or a guiding frame is the water security framework that UN Water, which is a coalition of different UN agencies working in the water domain, they sat together and they brought national experts, the international community, to see that we have a guiding framework to achieve water security. And this was also a sort of a watershed moment for the water research community globally and regionally and locally, because we talk about water security, but sometimes it's very difficult to understand how to design your plan, where to start, what all components should be the part of the checklist. And this guiding framework is only guiding. So we have outlined some core elements, as you can see in the inner circle, but also enablers, as in the form of good governance, as the previous speaker was also pointing to, that are prerequisites or very essential if we are to achieve the central components, thus ecosystem for water for the ecosystems, as again referring to leaving 2% or 3% water for the river, drinking water supplies, economic activities, industrial consumption, and in the recent time, focus on climate related impacts in the water domain. But again, not sort of ignoring other dimensions like transboundary cooperation, where a country like India also shares many of its river basins with the neighboring countries to ensure that those interactions are peaceful and political stability is maintained through sort of a consensus-based water sharing arrangements. And then of internal peace and political stability, that should be maintained as well, because the water recently or for water has also been a part of conflicts. I mean, when there is competing uses or conflicting uses, peace and political stability is then directly linked to the water domain. So most of our work surrounds these domains and sort of facilitating tools or developing frameworks and approaches by using innovative tools, including geospatial, but not limited to geospatial data and information. And we have specialized UN agencies who then work with us to fulfill those objectives. Another, again, water, I'm more or less setting the context about where we apply these tools. Again, the human right to water and sanitation is a core part of water management in many countries, where sometimes it's very explicitly represented and sometimes it's very distributed or segregated with different ministries or jurisdictions. So water right to sanitation. The overarching aim was to also bring together these different water sectors to apply integrated strategies. And this general resolution of the UN General Assembly 64/292 resolution that was passed around a decade ago is still in the process of being adopted by many countries. Many countries show resistance to kind of sign to this commitment because of several barriers, and these barriers could be financial resources. When you sign to something so specific, for example, let's read one indicator on the screen. The water cost should not exceed 3% of the household income. And when we asked this question to in one of our surveys in Sri Lanka, in one of the communities in Sri Lanka, peri-urban communities, they said that yes, we do get a supply of water in our house. We open the tap for water, but we never use that water for drinking. We buy water. So I think when you take a sort of a holistic approach to how much families or communities are spending to bear the cost of water needs for a household, it should not be more than 3%. Otherwise, their human right to water is not fulfilled. So these are like, again, overarching domains, but very closely connected to the water management plans, strategies, and monitoring frameworks that you apply at the national level, at the municipality level, at the basin level. And we at the annual scale, we produce these reports, World Water Development Reports. They are easily available as an open access document from the UNESCO website. And as people working in the water sector, we have contributed to these reports. And the 2019 report, Leaving No One Behind, was primarily about institutionalizing the human right to water approach and leaving no one behind, in the sense making the water discussions and plan more consultative. So it's and thinking beyond the supply demand supply dynamics that has been a conventional theory of managing water resources. We have shown the disparities, the inequalities using GIS maps. We have also used remote sensing tools to generate evidence to support some of our arguments in this report. And in the context of time, I'm not going into detail, but maybe I'll give you some of the academic research that went into populating these global reports. And very recently, one of our papers on tipping points, for example, has made a direct connection that water resource management cannot be separated from climate change adaptation or resilience planning discussions. And we have used telecoupling, and these are more academic or theoretical concepts, but these are fundamentals of refining and reforming the water planning. And in this, we have used, if you see, this is open access publications, again, available at a click on your browser. We've also gone into sort of a nuanced aspects of measuring indirect cause and consequences of water crisis. And in this case, we used how people are displaced, both internal displacement and international displacement due to water crisis situations, whether it is water quality linked to contamination or polluted water sources, water quantity, too much water or too less water at the seasonal or annual or long-term scale, and water extreme scenarios, which could be droughts and floods. And giving you a bit of a visual from these reports and publications. And these are like a global overview. So we have selected some case studies that represent either extreme water crisis settings or conditions where geopolitical stability is impacted because of water crisis. And Lake Chad is a classic example in Central Africa, where you can see on the screen right from 1973 to 21st century, the lake lost 80% of its surface water spread, and that caused a conflict because the fishers lost their income generation and livelihood. The farmers couldn't plant anything. There was a sort of a conflict about who's going to get water, how much. People are migrating to place where the water is left, as you can see on this the bottom image, where the red dots signify the shifting populations of people trying to resettle around the leftover water bodies, which is causing a conflict because of land rise and the water who is going to kind of let the other, informal and formal water resource strategies that were applied in Africa in general. There are also pastoral communities that move on a seasonal basis. So when the water is short, their rights are compromised at the first level. So a sort of a complex case where we wanted to use remote sensing tools and geospatial techniques, spatial temporal analysis to showcase evidence that yes, these issues need priority, and if we have to settle political conflicts, you may also have to look back into settling the water crisis. And similarly for Nile, which is also pretty much in discussion these days because of the Great Renaissance Dam that Ethiopia is making and how that would impact the domestic water water supply dynamics or water resources availability in the Nile downstream countries. So sort of again using remote sensing and GIS tools to showcase evidence, to showcase urban water nexus, to showcase shifting populations, change in land use and land cover, to give an evidence to these reports. And sometimes these models are constructed in a very complex manner and run at the background. But what I wanted to just emphasize here is primarily in the work that we do as United Nations agency, we use these tools to generate inputs. And the outputs are policy recommendations or development reports that highlight key priority actions for governments at the national scale or for regional organizations like SAARC or ASEAN or the African Union or the European Union. So working at different scales. And maybe before I close, I might also want to give an example from India, from our work back in 2005 to 2010, and we're working with the government and local agencies to revive and restore Lake Koleru, which is a Ramsar site in Andhra Pradesh, and that has been in a lot of controversies due to ill management, over harvesting, unregulated provision of resource use in terms of permits and subsidies, and again to give an evidence for the government to design a restoration plan, we casted the change dynamics in the water spread from 1977 using the available remote sensing data, and then showed them exactly how the surface water is now compartmentalized and used for aquaculture farming, and how that has impacts, and that should be more of a regulated process rather than a sort of a vast expense of a natural resource converted for some kind of a use without any proper guidelines. And in 2000, this was how the surface looked like. And after the Supreme Court order to abolish the aquaculture practices, some of these aquaculture farms were then left for the lake to be restored. So we could mark some buffer zones, the core zones, and how this plan should be structured by providing this evidence. And again, just for the closing, most of the work also is done at the global level by combining indicators, by combining different interlinkages between water stress and food security. For example, this map shows a global overview of how water stress, when juxtapositioned with the food security index, how the scene looks like, where are these zones that requires more attention in making that balance in terms of food security and water security. So giving those kind of background profiles for decision makers to refer when they have to. So this is more or less from my side, and maybe I'll use the leftover time, if we have any, for taking some questions.
Thank you, Dr. Nidhi. It was a wonderful presentation giving us an insight how UN is working in this particular sector. Now I would like to invite Yogita to take over and moderate this discussion and a Q&A session. Before I hand over to her, I would request all the participants who would like to ask any questions, they can raise their hands, and when your turn comes, you can unmute yourself and ask the question to our panelists. Thank you. Over to you, Yogita.
Thank you all our speakers at a time on the Saturday afternoon. It was really a very enriching session, understanding water resource management from different perspectives, from the perspective of water security, from the perspective of river basin planning, then impacts due to flooding, and then the context from the global scenario, how there are no borders when it comes to natural resources like water, and we need to go beyond the borders to get into water resource management. So we opened this house for discussion. That's what the format of Spatial Talks Webinar is, that we focus more on discussion and evolve a collaborative approach to whatever we are discussing here. Yeah, Mr. Sanghi. Hello.
Good afternoon. Good afternoon.
Good afternoon.
Are you able to listen to me?
Yes, yes.
Good afternoon. I am an ex-joint secretary with the NDMA and basically a telecom expert. I have three questions. First, from Mr. Prabhakar Shukla, he said that geospatial, whatever GIS and all these tools, models, these are very useful for collision of data and use in the disaster or otherwise planning during emergencies. But how to inform the public? That is the biggest issue, which we are not able to do as of now. We have seen Uttarakhand flash floods. Time was so short, we could not inform the public. J&K also, in spite of having maybe 7-8 hours, we could not inform the public, with the result that a lot of damage was there. Then my second question is, it is told that we have a lot of database which is free available, but high resolution database is not available free of cost. It is all controlled by ISRO, if I am correct. And with the result that whatever tools we create, whatever models we create, these are not being used actually during the disasters or otherwise. Maybe some departments, they have purchased some database, so they are able to use over a very small portion of the country. And we do not have a high resolution digital elevation map for the whole country, maybe only 20%, that sort of thing. These are my two questions, which are, I think, very relevant, how we can actually effectively use the GIS tools and models. Thank you.
Okay, to respond the first question about the information dissemination to the public. See, in my slide, I have shown about the application of GIS in the step 3. First was about the data handling. Second was about the hydrological modeling and getting some information from those data sets. And third was about the dissemination. See, what happens as a researcher, whatever we do, sir, as you might be aware, you are dealing with such projects throughout your tenure there. The projects get binded and they stays in the file, and maybe sometimes they are open or they are later. So what we do is, whatever research we are doing, we are creating a framework where the real-time water quality modeling outputs and also the real-time feedback from the simulation models, including the scenarios, the feedback will be given to that framework, and this will be translated into a simple, understandable language to the laymen. As an engineer, we do understand the technical terms, but if you talk about the people, those who are living in unauthorized colonies or those who belong to labor group or all those, it will not be feasible to inform that yes, there is a precipitation and this is the problem. You have to simply inform that yes, your area will be flooded and you need to vacate this, simply. So for that, we need to have 3 options at least. First and foremost is that everyone has access to mobile phone. So the information should be sent by the framework to the user directly on their mobile phone through a text, WhatsApp, or whatever it is feasible. That is the first way. Second way is to have a dashboard and having some application, mobile application, so that the user who are aware of things and they are capable of accessing the knowledge or grabbing out some inputs from it, they should be able to get some information on their fingertips so that they can make aware others also. So dissemination is I think most important thing, as a researcher or as a policy maker, whatever we are trying to do. And also, if you inform the stakeholders of any area that yes, this is being done in your study area, and what kind of problems you are facing, your voices should be heard. So if they are aware, then only they will send their inputs in the constructive manner to the researchers, and then only a solid baseline for the policies can be created. So dissemination is a very important part, although we are lagging in that. But many agencies, they are doing this. For example, Team IT Delhi, the same research group, they have worked in Kolkata for the real-time urban flooding, and they are using this practice there. Even other department, apart from this water resources, for example, the earthquake and all these things, many times they are sending warning messages. Hopefully, in the coming days, this will be implemented in the Delhi also once our project is over. So we are very hopeful that this problem will be solved. At least at some scale, we cannot say 100%, but up to
No,
some
I agree. I agree. It is not expected from you. You are doing you are part of the job. Actually, this is the basic requirement which is lacking, and it is not that easy. It is not that easy to bring that seamlessly in the minimum possible time, so that without knowing the mobile number or so the location of the person, we should be in a position to inform that, because the mobile doesn't work. Because at that point of time, he may be in Bombay and the problem is in Delhi. So the message will go to the person in Bombay. So what we need is a message to the people over there in that jurisdiction, so that he gets in the minimum possible time. That is basically requirement.
Yes, we thought of that. We thought of that also. This was raised during our internal discussion also. So what we have done, that we have collaborated with the Delhi Jail Board. There are registered mobile numbers for the people who are paying the water bills in the local area. So we are using that number, assuming that this number is within Delhi itself, because they are using that number for just.
In case I have 2 minutes from the chair, I can give you a real input regarding this dissemination of the information, which is a recently development in the world as well as in India. And I was associated with that. There is a common alert protocol. Kindly see on internet, common alert protocol. This is the technology where, without knowing the mobile numbers of the people, if you as a disaster manager or as a agency of early warning agency, you set a GIS contour, that is you send the polygon, GIS polygon, that's all. That is the only requirement. This is the polygon where we want to inform the public, that's all. And now that polygon goes to a central server, a computerized server, where it is sent to all the telecom companies, and next 1 minute they see which are the towers in these polygon, and all these companies, whatever message you will send them, they'll further broadcast that message, and this happens within 2 or 3 minutes, and the message goes to those people actually in that area. So this has already been tried in the country. So you can just check up that, and you can integrate your whatever research and whatever output you are bringing, that can be integrated with this to be more effective for the disaster managers as well as the public. This is the input I am giving.
This is really very.
Thank you, sir, for the input, and we will definitely look forward to it. Regarding your second question on availability of geospatial data, so you might be aware of the new geospatial guidelines which have come, and they have opened up, India has opened up the acquisition of geospatial data by Indian companies. And now we would see more of geospatial data availability on an ongoing basis. So that's the answer to your second question.
Madam, data is already available with ISRO, but that is made available at a heavy cost. So the high resolution data, where we can save the people, we need a high resolution data, like what one of the speakers said.
For that, there is already an international protocol of sharing that high resolution data. So I'll connect with you personally on that. That there is a protocol for such disaster management things where high resolution data is shared at immediate basis.
No, but not 0.6 meter. Not 0.6 meter.
Yeah, that is also Digital Globe and all these agencies like Planet, they do share it. So we'll connect you with those people. And
okay, thank you.
Dr. Nand Kumar.
Yeah, it's a nice presentation by the participants. I'm very happy to listen to the workshop. It's an excellent presentation. And the very important thing is that people from remote corners all over the globe are able to participate in the meeting. That itself is an advantage. And
Thank you.
yeah, and with regard to the, for example, I was just listening to Nidhi Bhatta from United Nations University, then different people across the globe. Yeah, it is really fantastic, actually. And coming to India about the data, he was talking, Prabhakar Shukla was talking about the data availability. Of course, we have to bring down the cost. That is possible when more people are using it, and ISRO has to take care of the reducing the cost.
Yeah.
Because and a large number of data is already available in the public domain. If we go look for the older data, plenty of data is there, and we have to use it, and they have to bring down the cost. That is the.
Thank you, sir.
Yes.
Any more questions from the participants? So I would have one question as to like we have, because water resource management is quite vast area, and it requires a lot of multiple departments and authorities to take care. For example, if we talk about the surface resource management, there is a different ministry and different departments which are taking care. Then we talk about the groundwater management, there's a different agencies which are taking care. Then we talk about irrigation management, there are different agencies which are taking care. Then come to the disaster management aspect of it, there are different agencies. So how can we, and then we have public by large, and I'm more concerned because now water is being, it is now being run as a commodity at New York Stock Exchange. So where are we actually going forward to, and how we can, using the geospatial technology, we can bring in an integrated water resource management which cut across all these things. And the other important aspect is of the water harvesting, because we get water, but how we are actually able to store it and manage it is where we need to look into it. So my questions to the panelists, whoever is to give this answer for this question, because how can we do this integrated? Because the research and everything, and at policy level also, there is a lot of inputs being given, but every year we see the flooding, every year we see this kind of thing. So how do we actually, get this information to be used by the users, the end users, and public by large? So Nidhi, you'll take up this question?
Yeah, I would like to answer this question. That for this, every year flood is coming and devastation is there. For that, government has taken a lot of initiative. First of all, the first initiative was they have started awareness program, and second one, they have started in the curriculum for the school children's. Earlier it was in 11th, 12th, and now it has been started 8 to 10. It is going to be implemented maybe this year, and now they have made compulsory one, you can say, the semester to create a youth about this disaster and how to reduce the risk. So it is mandatory. So I think that is the initiative, and we believe that there is a lot of initiatives have been taken by the government in different sectors, and in coming days we will be able to control this flood scenario in you can say the channelize energy in the right directions.
I think yes, in the similar directions, this flooding and then dissemination of informations, kind of where is the flooding is going on. So there is a very good setup in within the WRD of Maharashtra also, where they have calibrated and validated the integrated reservoir planning, where they use the rainfall data, forecasted rainfall data, and model it and then see the impact downstream, and then immediately they inform to those stakeholders. So technology also and the model is also in place in many of the not many but few of the states. They have taken up these actions under various projects like National Hydrology Project. They have taken up this integrated reservoir planning, where the flooding and its consequence can be minimized with the advance warning. So that is already taken care. And second question is the integrations. Now earlier we were working in the silos. Now the things are changing, and the need of the hour is also that, and the government is also recognizing, politicians also recognizing, bureaucrats also recognizing these things. Now there is a need to will, as well as there is a need to a leader to go and bring out these initiatives, like Karnataka has taken up this Advanced Center for Integrated Water Resource Management. See, unless integration will never happen unless you have an entity. You must have an entity to coordinate with all the, no department will coordinate with each other. There is a single protocol, single government, highest authority of the government. They have to decide that, okay, we have to bring it this synergy into various departments. Then only it will happen. This is my sincere, and it has happened in the Karnataka also. They have taken up this initiative, and under the leadership of Chief Secretary and the Additional Chief Secretary and Principal Secretary, it is being now under implementation. So this happens only with the political will and with the bureaucrats' will.
Nidhi, your input?
Very quickly, yeah, I will also emphasize on the point of building capacity of youth as well as of all the stakeholders who are involved in managing water directly or indirectly. Yes, integration is certainly something that is challenging for governments, because there's a certain way they get used to in doing things, and when you change change is necessary but it's not easy. And I think taking some lesson from that, there are several frameworks and operational guidelines for integration. The challenge is political will, as our colleague pointed out, but also understanding the governance perspective. And at one of our projects here, we are working on multi-level governance frameworks, and in theoretical terms it's called polycentricity, but it's like giving understanding competencies, capacities, but also kind of empowering people who can take action. So a sort of delegation of authority at the right times and for right things. So these are complex governance mechanisms. And we have, as a country, India has done a really good job in technology advancement, in applying sort of institutional mechanisms to creating institutions, deploying plans and projects and programs, and I think millions of dollars for boosting water management planning. But I think somewhere where we have to monitor gaps in needs, and I think boosting governance mechanisms for delivery, for monitoring, for a sort of performance assessment. I mean, why are businesses successful? Because they have a M&E strategy, monitoring and evaluation strategy in place. But in governance, in sort of a public governance, there is no M&E. I mean, who gives a certificate whether we are doing good governance or not? Yeah. So I think, yes, these are difficult questions, and I think this needs really dedicated, long discussions, but I'll limit and pause to that. Thanks.
Yes, I would like to add few more points. I would like to add on few more points that you know that India has a very long coastline, and in every coastline we face cyclone every year. And after the cyclone, near about 3 to 4 kilometer area has been inundated. So earlier we have 5 steps of warning system which has been issued to the community. But now government has upgraded, and now it has been changed into 7 steps. So in the previous 6 steps, they give in certain duration, but in 7 steps, they provide information, or you can say awareness every second, every minutes they provide. And result of this, that now we have a very, you can say, small human loss, which in 90s, if we talk about, that was the time then we have near about 2,000 people, they have lost their life. But if you compare from that to today, so we have near about 5 to 6 people, they lost their life. Only because of that, they are not ready to listen and they are not ready to evacuate. So if we compare this warning system from all over the world, India is number one. At the same time, US, they have faced the Katrina cyclone, and there is lot of chaos. No management was there. But at the same time, India, they have managed this cyclone very wonderfully. And it has been appreciated worldwide. So we are doing wonderful job, no doubt.
Yes, I agree to it that our cyclones management and that's where the geospatial technology has been the backbone in providing those kind of early warning systems, not just in cyclone but also in tsunami and also in flooding situations. What I was trying to emphasize is that when we talk about water resource management, we have to see it from a complete holistic perspective. And the next level, so we now know that technology is in place. We understand that there are a lot of application solutions there are in the place. The next level where we have to take it up to is get it penetrated into our governance mechanisms. This technological penetration into the governance mechanism so that the delivery is made ensured. And I think that is where the next level of focus should be, that how we can, take these technologies forward to at multiple governance levels, from the local to regional to national, and then collaborate with the global agencies. Because as we see that even in India, the river basins, the origin is from the Himalayan region. Most of the part is of the source lies in the Chinese or the Tibetan region. Then we share it with other countries also. So we need to have such kind of frameworks, where these kind of intergovernmental, within the government, at different governance levels, a kind of synergies, so that we treat the water resource management at the local, at the regional, and at the global level in a holistic way. So, is there any more questions? Or
I just wanted to add what you said in the beginning, that you need to create a integrated system. No, so we need to create an integrated system at the national level based on the geospatial technologies, fully integrating all the departments, whether it is the irrigation department, CWC, or Indian Meteorological Department, or disaster department. All those are to work on that platform up to the public, so that further all database is at one place, and all these stakeholders use the database to use it effectively for planning, for crisis, for disasters, and all that. That is what is the need of the hour. And technology is available today. Only decision, and then further how the state and the center responsibilities need to be fixed, and then you have to roll out. That is what is the basic requirement. That's, I think, you wanted, you pointed out in the beginning. Thank you.
I just wanted to answer, just wanted to say that everything is there. Integrated approach is also there. Every department, they are coming together when the scenario is come to the disaster. So if you see the example of COVID, where every department they come and they provide all the information to local communities.
The physical level all work together.
Let me finish first. The first thing, the most thing that where we are lacking, everything, technology is there, integration is there, government is taking their role, and even our honorable Prime Minister, he is taking active action. Lacking is only that we, the common people, they are not aware that resources are there and how to use. So again, the point come to the capacity development. So there is a lag between those things.
I would add to it, Mukta, that it's not just the people, but also the end user department the governance, you know, because at the governance level, there is a huge issue. So in silos, we are working. Some departments are doing very, very good, but then there are certain departments, the municipalities, the local bodies, you know, this is where we need to strengthen. And as we said that we don't have a monitoring and evaluation scheme, this needs to be put into place. So there's a water supply scheme, but you know, the implementation is who is going to implementation, how it's going to be implementation. So there are still challenges at the governance level. There are few departments who are doing very well, but there are few departments where the integration is still required.
Lot of capacity building is required.
Yes, lot of
Various
capacity
levels.
building is required.
Yes. When you talk, it will come that capacity development is the main crux of all the things. If that is there, things will work out. If you compare, if you see the COVID, government has done its full efforts, but even people are not ready to listen what we can do. It's totally helpless condition.
Hello.
Hello. Yeah, I think.
Mukta, we lost.
Yeah.
So let's conclude.
I think Dr. Shukla wanted. Yogita, Dr. Prabhakar Shukla wanted to say something. I think he had a.
Okay. So,
Dr.
so,
Shukla?
Yeah, your question was like how we can use GIS for integration of different departments, right? So I have few points to add. First thing is about the we should use a GIS platform to connect the data across the organization. For example, CWC and CGWB, they are collecting the water samples at different locations at different time. But both of them, they are not exchanging their digital data sets. They are simply putting it
exactly.
One department don't know what other is doing. So the best way is to keep them in an open source, and there should be digital submission of such reports and data sets. There should be a portal where all these things are available. Note, if there are restriction of data sets, I understand there are policies for that. At least to the department or the government officials, those who are there, for them this facility should. This is the first thing. So GIS can help us there. And second is about this the data portal which I have mentioned. And the third thing is about there should be an open call for implementing an automated system with the minimal effort. And that is possible only when the things are in open source and the transparency and the understanding is there. So these are 3-4 things which we can do implementation of this GIS and the related things in making this. And also, like in different countries, there are provision for exchanging their recent developments. Same should be true for the intergovernmental departments which are there. They should know and they should share their views, their observations, their critical points or the hot spots with the other departments so that they are aware of their activities. There should be some legal or some contract type of thing so that they are bound to do that, and there should be right to sue and getting sued by the people those who are working that field. Then only things will be in place. Obviously, the others have mentioned about the capacity building. I will take only 2 minutes, giving an example of what we have recently faced in Delhi. First thing is that when we are talking about the policymakers or all these things, I don't know whether you are aware or not, there is no water policy for NCT of Delhi. It is still in the discussion phase since a long time. And we are sitting in the capital where groundwater depletion is a international issue. There is no water policy, so it's a political with power as well. And second thing, when we I won't quote any agency here, but when we give some something related to water sector to the government department, and surprisingly, even after 4 years, they simply say that we don't have manpower to understand your technical outcomes. And when we told them that we have trained your people, more than 30 to 40 people were trained, and we have spent so much money on them, then they simply said that it's a policy of government that people keep getting transferred. So we can't help that. So there are such challenges as well. Even if you make some capacity in the department, there are policies that they'll be transferred on another day. So this needs to also be considered. And that's the reason that there are frequent flood episodes in Delhi. It's in news so many times in news and the discussions as well.
No, I totally agree with you, Dr. Prabhakar, because that's how, and that's what Mukta has also been talking about, that we need to have a capacity development, capacity building on an ongoing basis, so that everybody understands the power of spatial thinking. Right now we don't really think spatially. Our decisions are not centered around spatial way. So the capacity development activities, they need to be done on an ongoing basis. And yes, challenges are there, but that's what they are for. And we have to convert them into opportunities as to how we can deliver more through the use of the technologies and able to support at the grassroots levels. So I think we would conclude at today's session, and it was really a very thought-provoking and enriching session, considering that water is a very, very fundamental component to our existence, and it needs a lot of further discussions also. Beyond just technology, how we can take it forward. So I would request all the participants to share their suggestions so we can, build a report, create a report from this webinar, and we can submit it to the Government of India and take it further from there. So thank you so much for being with us.
Thank you.
Thank you all.
Thank you.
I
would like to thank all our speakers for taking out their time in their busy schedule and being a part of us, and above all to all our participants for their patient hearing from the beginning to the end. So thank you very much for being here. And now we like to conclude the webinar, and we'll hope to meet you next year with more interesting topics. So look out and watch out our space on the social media as well, where we keep on posting our new webinars which are coming up. Please go and visit our new website as well, www.wgc.org.in, and give your feedback to us over there as well. Thank you so much.